Bright Duty. Every student matters.
Hello students. So as we have discussed the divisibility rules, now we are going to practice some question based on those divisibility rules. So let's get started. And here is our first question. Using divisibility test, determine which of the following numbers are divisible by 2, by 3, by 4, 5, 6, 8, 9, 10 and 11. So they're asking us to just say a yes or a no. If the number is divisible, we have to say a yes, otherwise it will be a no. So let's get started with all the parts as they're here. Okay, the first number that we are given here is 128, and for that they have already written the answers. Okay, so this way only we have to solve it. The second number that is here is 990. So do you think it is going to be divisible by 2? Let's recall the divisibility rule for 2, or divisibility rule by 2. What we see in that the last digit of the number, that means the units digit, the ones digit of the number should be either 0, 2, 4, 6 and 8. If out of these we have this as the last digit of the number, that means the number would be divisible by 2. So here when I see for 990, we can write yes because the unit digit is 0. So we will write a yes here. Clear? Now 990. You have to check for 3. Is 990 divisible by 3? Recall the divisibility rule by 3. It says you have to add up the digits of the number given, and if the sum comes out to be a multiple of 3, or if the sum is divisible by 3, this number which is given to you will be divisible by 3. So you can see there are 3 numbers, 9, I say there are 3 digits, 9, 9 and 0. Just add them. 9 plus 9 would be 18. 18 plus 0 is 18. So do you think 18 is divisible by 3? Yes. So we say 990 is divisible by 3. So we're going to write a yes here. The next is question number. Okay, next is the divisibility rule by 4. The number is 990. What do you think about it? What is the divisibility rule of 4? Either you can divide it, check it using the long division method that we do, or what we can do is we can look up at the last 2 digits of the number. It is 90. What about 90? Is it divisible by 4? The last 2 digit, and the number formed by the last 2 digit is 90. So you have to divide it with 4. That will be 4 2s are 8. You will be left with the left with the remainder as 1. Copy down 0. Then 4 2s are 8. Okay. So you are left with the remainder as 2. So it is not exactly divisible by 2. So this number 990 will not be divisible by 4. So here we will write a no. The next part is divisibility by 5. 990 divisibility by 5. What does the divisibility rule for 5 says? It says the unit digit or the last digit should be either 5 or 0. Here we see it is 0. So yes, it is divisible by 5. Now when you check the divisibility rule for 6, you need to see whether the number is divisible by 2 as well as with 3. So yes, 990 is divisible by 2 as well as 3. So it will definitely be divisible by 6. So we're going to write a yes here. Divisibility rule of 8 says what if it is a 3-digit number, you can just divide it and then get to know whether it is divisible or not. If it is more than 3 digits, then you can take the last 3 digits of the number. Okay, and see if the number formed by the last 3 digits is divisible by 8 or not. So here the number is 990. Let's try dividing 990 with 8. Okay, starting with 8, I will write 8 ones are 8, remainder is 1, copy down 9, then 8 twos are 16, you are left with 3, copy down 0, okay, then 8 threes are 24 and 8 fives are 40. So then 8 fours are 32. So I should go with 3. 24, 6 would be the remainder. You say it is not exactly divisible by 8. So we will say no here. Now divisible by 9. Again the divisibility rule of 9 says the sum of the digits should be divisible by 9. When I add 9 and 9 it comes 18. Okay, and that is divisible by 9. So we will write a yes here. When you go for 10, the divisibility rule of 10 says that the last digit of the number should be always 0. And yes, 990 is the number in which the last digit, or I say the unit digit or ones digit, is 0. So yes, it is divisible by 10. About 11, 990 is there. Okay, so what is the divisibility rule? It is a 3-digit number. We can try dividing it and we will get actually that it is divisible by 11. 11 ones are 11 and 11 nines are 99. Just see. So 0 and you copy down 0, here you will get 0. So 90 would come up, 0 would be the remainder. So yes, it is divisible. Otherwise, if the number is more than 3 digits, what we can do for the divisibility rule by 11, you have to name, first of all, name the positions as 1, 2, 3, 4, 5, 6. Then you take out the digits which are at even places. You take out the digits which are at odd places. Okay, you add the digits at odd places, you add the digits which are present at even places, and you take the difference of those two sums. If that comes out to be 0 or 11 or a multiple of 11, we say the number would be divisible by 11. Okay, let's practice the next one. Let us do the second part now. In the second part, the number given is 1586. Okay, we have discussed about 990. Now the number is 1586. For the divisibility rule of rule by 2, we have discussed the unit digit should be 0, 2, 4, 6 or 8. If the unit digit is any one digit out of these digits, then we say the number is divisible by 2. So yes, 1586 is divisible by 2. So we will write a yes here. Now, after 2, we have to check the divisibility by 3. 1586. Let us add all the digits. 1 and 5 is 6. 6 plus 8 is 14 and 14 plus 6 is 20. Is 20 divisible by 3? No. So we will say this number is not divisible by 3. You have to write a no here. Now divisibility by 4. Just pick up the last two digits. That is 86. Okay. 8 and 6 and the number formed is 86. Try to divide 86 with 4. Is it completely divisible? No. So we will say this number is not divisible by 4. Now comes the rule for divisibility by 5. Then 1586, the unit digit is not 0 or 5. So divisibility rule by 5 says the unit digit should be either 0 or 5, then it will be divisible by 5. So this number is not divisible by 5. So you have to just mention here no. What about 6? A number is divisible by 6 if it is divisible by 2 and 3 both. But here it is only divisible by 2 and not by 3. So we will say this is not divisible by 6. Eighth part, divisibility by 8. So 1586 is there. Take out the last three digits, that is 5, 8 and 6, and the number formed by last three digits is 586. So you have to try dividing 586 with 8. So 8 sevens are 56. You are left with 2. Copy down 6. 8 threes are 24. You see it is not exactly divisible. So we will say a no here. This number will not be divisible by 8. For 9, we have added the digits in case when we were checking for 3 and we found the sum to be 20. But 20 is not divisible by 9. So we will say no. For 10, the last digit must be 0. Here it is 6. So not divisible. Divisibility rule of 11 says we have 1586. Take the digits alternate, that means at the odd places and even places. So if I position them 1, 2, 3 and 4, you see I will take up 1 first number digit, that is 6. I will take third number digit, that is 5. So it gives me 11, and 2 and 4 digits are, that means the second and fourth place digits are 8 and 1. That gives us 9. If you take the difference, it will give you 2. Okay, not a multiple of 11. So we will say this number will not be divisible by 11. So this way we have to write for all the numbers. If it is divisible, you just have to mention yes, and if it is not divisible, you have to mention no. So this way complete is to be done. So let's discuss some more parts of the same question. Let us now check for 275. It is an odd number. Also the last digit you see is not 0, 2, 4, 6, 8. So this is not divisible by 2. 275 is it divisible by 3? Just add the digits. 7 plus 2, you will get 9, and then add 5 to it. That means what I'm doing, I'm adding the digits. How? 2 plus 7 plus 5. Okay, 7 and 2 is 9, 9 and 5 is 14. So not divisible by 3. Is it divisible by 4? So the last two digits forms the number, that is 75. And 75, do you think it is divisible by 4? No. Then we have 5. Yes, it will be divisible by 5 because the last digit, the unit digit is 5. Is it divisible by 6? Just think about it. What does the divisibility rule by 6 says? It says that the number should be divisible by 2 and 3 both, but here the number is not divisible by any of 2 or 3. So it will not be divisible by 6. What about 8? Try dividing 275 with 8. Okay, so 8 threes are 24. You get the remainder from here as 3. Difference as 3. Copy down 5. 8 fours are 32. See, you are left with the remainder not divisible. Okay. Divisibility rule of 9 says that add the digits, and when we added, the sum was coming as 14, not divisible by 9. So we'll write a no here. Divisibility by 10 says that the last digit, or I say the unit digit, should be 0. It is not in this case, it is 5. So we will say no. Divisibility by 11. So you just add up the digits, like 275 is there. 3 digit you can definitely divide it also. So you take 1, 2 and 3, add 5 and this. So 5 and 2 is 7, and then this is 7. So when you will subtract these two digits, you will get the answer as 0. 7 and 7 will give you 0. So yes, it will be divisible. Also, when you divide, this is just a 3-digit number. You can try dividing with 11. So 11 twos are 22, and you're left with 5, and you also will copy 5. So 11 fives are 55. See, you are getting the remainder 0. It is exactly divisible. So this is how you check for all of these numbers in this question. So we can pick a larger number as well to do, and then we can proceed with other questions so that you know how to do. So let's discuss one question where number of digits is more, also the number is greater. So these were some smaller numbers, 4 or 3 digits. Now I'll discuss some other part of the question where we have a larger number. So let's discuss now this part. Okay, it is 0 639,210. 6,39,210. This is the number. Okay, if we check divisibility rule by 2. For divisibility rule by 2, so let us check if this is divisible by 2 or not. Divisibility rule by 2 says that the last digit, the unit digit, should be either 0, 2, 4, 6 and 8. And here it is 0. So yes, it is divisible by 2. For 3, we have to add the digits. Let's add them. 6 plus 3 plus 9 plus 2 plus 1 plus 0. Let's add them. 6 and 3 is 9. 9 plus 9 is 18. 18 plus 2 is 20. And 20 plus 1 is 21. So yes, 21 is a number that is divisible by 3. So this number will also be divisible by 3. You will write a yes here. Now divisibility by 4. So just take out the last two digits and see the number formed by them. The number formed by them is 10 and it is not divisible by 4. So this number is not divisible by 4. Divisibility by 5, yes, it will be divisible by 5. You can see the last digit or the unit digit is 0 here. So yes. Divisibility by 6, yes, we can say it is divisible by 2 and 3 both. So yes, it is divisible by 6 as well. Now, when I see divisibility by 8, just take out the last three digits, that is 210. 210 is the number formed by them. Try dividing it with 8. 8 to the 16. You are left with 5 and copy down 5. 8 6 are 48. You see, not divisible. We'll say this complete number will also not be divisible by 8. Divisibility by 9, we have to add the digits and we have to check the sum. So it was coming as 21. Is 21 divisible by 9? No. So we will say it is not divisible by 9. Then 10, yes, the last digit is 0. So yes, it is divisible by 10. For 11, what we will do, I'll write the number. It is 6,000, sorry, 6,39,210. Place the digit numbers 1, 2, 3, 4, 5, and 6. Take out the digits first at odd places. That means first, third, and fifth place. First place it is 0, third place it is 2, and fifth place it is 3. So the sum is 5. Now another digits that are placed at even places. At 2 it is 1, okay. At 4 it is 9, and at 6 it is 6. So 9 and 1 is 10, 10 plus 6 is 16. So when you subtract 16 minus 5, you know you will get 11. Yes, the difference is a multiple of 11. It can be 0, it can be 11 or a multiple of 11. So yes, it is going to be divisible by 11. So we will say yes, it is divisible. So like the students, we can check up for all. So just by using the divisibility test as discussed. So for some of the parts I have discussed in the class, rest you can try at your own. At last, when you check all the numbers and their divisibility by 2, 3, 4, 5, 6, 8, 9, 10, and 11, this is what you are going to get. So just try out all the parts and let's move to the next question now.